Hi everybody, welcome to this video. And so in this video, we're going to apply the idea of a Riemann sum to approximate areas underneath a graph. So let's go ahead and read through what the definition of a Riemann sum is. So we can approximate the region R, shown below, by splitting up the interval A to B. We're going from A to B into n subintervals, finding the area of each rectangle corresponding to each subinterval, and then adding up these individual areas. So what we're going to do is cut up the desired area we want into subintervals, where each subinterval is going to give us a rectangle. And what we will do is find the area of each of these rectangles, add them up to get the entire area underneath the graph. And so, how do we figure out how to cut these rectangles up? So there is, depending on how many rectangles you want, we can divide up each rectangle into the same amount of width called delta x, where delta x is the width and it's b minus a over n. And that'd be the width of each rectangle. So what we would have here is delta x, excuse me, delta x, and it'll be the same over here, delta x. Each of these rectangles are going to have the same width. And we would have different subintervals of x0 to x1, x1 to x2, and etc., where x0 is your A and xn is B. But that's all we're really doing is creating rectangles, finding the area of each one underneath the graph, and summing them up. So let's go ahead and try an example to really get a hold of what we are discussing here. So example 1 says use n equal 4. So that n equal 4, that means 4 rectangles. The question is telling us it wants us to use 4 rectangles to find the area under the curve of the function f of x equals square root of x on 0 to 4. So the 0 to 4 is our A to B. Okay, so here's our function here below on the graph, f of x equals square root of x. So I want to find the area underneath f of x. So it says use left endpoints. We'll get to that in a second. But the first thing you always want to do with these questions is to find your delta x. So delta x, remember the formula is b minus a over n. Our b here is 4. A is 0 over n, which is 4 rectangles. So this is 4 over 4, and that's just 1. So delta x equals 1. And remember, this is our width of each rectangle. Okay, so since delta x is 1, that's our width. Let's go ahead and jump to the graph and build out our rectangle. So our width is 1. So on this graph, I'm going to go by 1 until we get to 4. So here's a delta x, and that's a width of 1. Here's a delta x from 2 to 3, delta x, and then from 3 to 4, that's a delta x. So I got my 4 delta x's, and that means we have 4 subintervals. We're going from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Okay, so we have our subintervals of what our rectangles would be. Now let's look at what the question is asking us, left endpoints. So that what that means is that it's the left endpoint of each subinterval. So if we look at our each subinterval, this is left endpoint, right endpoint. Left, right, left, right, left, right. So when it says use left endpoints, I'm going to choose the left endpoint of each subinterval. So in this first subinterval from 0 to 1, I'm choosing the left endpoint, which is 0. So wherever 0 is on our function, I'm going to put the point there. And likewise, from 1 to 2, the left endpoint is 1. So I'm going to put our point wherever 1 is on the graph. 2 to 3, here's 2. Last one is 3 to 4. My left endpoint is 3. So here we are there. So I'm using my left endpoints. Notice that 4 is not included. I'm not drawing a point of 4 because 4 is only a right endpoint. It's not a left endpoint at all. So let's go ahead and draw out our rectangles. So the way to do this is you're going to go over, and that's our first rectangle. Same thing here. I'm going to go over and go down. That's our second rectangle. Got to connect them, but then you go over and down. That's our third rectangle. Connected, and once again, go over and down. Okay, go ahead and shade in our rectangles. Okay, so also notice that the height of each of these rectangles is the function at each of these left endpoints. So the height of our first rectangle is f of 0. The height of our second rectangle is f of 1. The height of our third rectangle is f of 2. And the height of our fourth rectangle is f of 3. Wherever is touching the graph, that's our height of it. Okay, so now that we have our 4 rectangles, the last thing we got to do is add up the area of all these rectangles. So recall that the area equals length times width, but in this case, you can also change it to maybe the height times the width. And so the height of this first rectangle is f of 0. F of 0, and the width is delta x. I'm not even inputting any numbers yet. I'm just writing out what they are before plugging in numbers. So that's the first rectangle. And now the second rectangle, our height is f of 1, and our width is once again delta x. So f of 1 times delta x. Third rectangle, our height is f of 2. So plus f of 2, and our width is still delta x. And our last rectangle is f of 3. That's the height. And our delta x is the same. Our width is still delta x. So let's go ahead and plug in these numbers now. So f of 0, well, where is f of 0? It's basically 0. Square root of 0 is just 0. So this would be 0 times delta x, which is still just 1. And then f of 1 right here, square root of 1 is just going to be 1. So plus 1 times 1. Delta x is still 1. And then f of 2, that means square root of 2. We don't have an exact answer for that, so I'm just going to leave it square root of 2 and times our width, which is just 1, delta x. And lastly, f of 3 is square root of 3. Don't have an exact answer for that, and times delta x, which is just 1. So if we simplify this, it becomes 0 plus 1 plus square root of 2 plus square root of 3. And you can just plug this into your calculator. And what you should end up with is 4.15. And that would be the area underneath square root of x using left endpoints and 4 rectangles. Okay, so that is left endpoints. You can also use right endpoints. That's another method. You can also use midpoints between your subintervals. But all these are going to give us approximations. It's not going to be the exact answer. You can do 4 rectangles, 6 rectangles, etc., but they're not going to be the exact area. So that's where the definite integral comes into play. But we'll get there in the forthcoming videos. But that's it for this video, and I'll see you next time. Thank you. Bye.